Hello, my name is Trent Roberts. I'm Associate Professor and Soil Fertility Extension Specialist with the University of Arkansas System Division of Agriculture. Today we're here at the Pine Tree Research Station where I want to talk to you about the work that we've been doing with cover crops, soil health, and in soybean rotations. The current study that I'm standing in has been a cover crop no-till soybean rotation for 5 to 6 years. And part of what we've looked at in this study is a comparison of different cover crop treatments from fallow, different winter cereals, different winter legumes, different blends. And then in the early stages of this particular study, we actually compared it to a wheat double crop system. Part of what we wanted to do with this trial is look at the influences of cover crops and wheat production systems on things such as soybean yield, soil health, and then the economics, which we looked at partial returns in this particular system. So the first thing that I want to discuss are some of the differences that we've seen in yield over the course of this study. Now what I want to do is preface this by saying we've done this particular study at 3 different locations across the state for a minimum of 3 years to build the data set that I'm going to be talking to you about today. So our first location is here at the Pine Tree Research Station in St. Francis County near Colt, Arkansas. The second location is going to be at the Rower Research Station in southeast Arkansas in Deshay County. And the third location is going to be at the Vegetable Substation near Kibler, Arkansas in Crawford County. And the reason we chose those 3 locations is it gives us different environmental conditions, it gives us different soils to look at, and then it's just going to change the way the soybean react to the environment as well as the cover crops. Now the cover crops that we're looking at in these studies, as I mentioned before, there's a wide range, but the key thing that we wanted to do was try to compare to what we consider a traditional system that still includes tillage but does not have any type of winter cover crop treatment. And then on the other end of the spectrum, we have a traditional wheat soybean double crop system where the wheat is grown and produced for grain and then followed by soybean after wheat harvest. Now, one thing that we hear a lot as agronomists across the state is people don't like the wheat double crop soybean system anymore because waiting to harvest the wheat, significantly pushes back your soybean planting. And we know that there's a very strong relationship between soybean planting date and yield potential. And so one of the comments that we get a lot from producers is, the yield that I lose from planting my soybean late following wheat is too much of a profit loss for me to continue with that system. And that's part of the reason we wanted to include that in this study. So if we just talk about yield first, the one thing that I want to mention is that we did see significant differences across the cover crop treatments, with our highest yield being about a 3-year average of 63 bushels per acre, and that came following our Blend 2, which is essentially a 50-50 split of Austrian winter pea and black seeded oats. And so that was our best yielding treatment. If we compare that to our fallow treatment, the fallow treatment yielded about 57 bushels per acre as a 3-year average. And then our lowest yielding treatment was that wheat double crop soybean system. And it came in at about 53 bushels per acre. So what you can see is the range from our highest to lowest yielding treatment was about 10 bushels per acre, with our traditional, what we would say, producer practice coming in right at the middle of the pack. And so we do see significant differences in soybean yield as we implement these different crop production practices, with our highest yielding treatments coming following cover crops in rotation. The next thing that I want to talk about is partial returns or profitability. So when we talk about profitability of soybeans, we often refer to it as a partial returns type of an analysis where we're looking at variable input costs. So if you think about the different crop rotations or cover crops that we're implementing across this study, we're going to have different seeding costs, we're going to have different tillage costs, We're going to have different herbicide burn down costs for the cover crops. And so what we wanted to do is try to capture all of that in our partial return analysis. So if you think about some of the differences that we're going to see, let's first start with the fallow. So with the fallow treatment, we obviously have full tillage, but we're only going to have a single burn down for any winter weeds that may occur. But one difference about that fallow treatment is we don't have any winter cover crop seed cost. Now, if we shift over to a generic cover crop type treatment, you have to understand that we're taking tillage out of that rotation, because when we implement cover crops, we can only truly realize their full benefit when we also implement no-till practices at the same time. And so when you think about that, yes, we're adding the cost of cover crop seed to that production system, but we're also removing tillage from the equation. And one thing that we've found is that in a traditional soybean production system with full tillage, the cost of that tillage, the labor, the fuel associated with it, can equate to about $30 per acre. And that's a very significant cost that will oftentimes more than pay for cover crop seed, planting, and at least a part of the termination cost. So those are some differences in that system. When we move over to the wheat double crop system, there's a significant amount of cost input or change there, because we have the wheat for grain seed, which is typically higher than a cover crop seed. We're going to have in-season herbicide weed control for the wheat crop. We're going to have additional fertilizers for the wheat crop. And then we're going to have an added planting pass and some other things there. But we also have the revenue from the wheat crop to help offset some of those increased input costs. So when we start talking about partial returns from all these production systems, the one thing that we found is that our highest partial returns were seen from the majority of our cover crop treatments, but they were also very high in our wheat double crop system. And so there were no statistical differences in the partial returns of our double crop system compared to some of our higher yielding cover crop treatments. And so the message that I'm trying to relay there is that a wheat soybean double crop system can be profitable, right? You will lose yield in your soybean due to the late planting, but oftentimes the value of the wheat crop that we can grow in the interim will make up for any potential yield loss that we see in the soybean. I will kind of preface this by saying the soybean and wheat crop values that we used in our partial return analysis was the last 10-year average. And so we felt like that was a good number to use to capture potential fluctuations or changes in those commodity values over time. The last thing that I want to talk about in this particular study, and something that we'd be remiss not to mention, are potential changes in soil health. So one thing that we hope to do with the implementation of cover crops and no-till production systems is increase soil health. And so in this particular study, where we've had no-till and cover crop rotations over time, we've seen numerical increases in both soil health and soil organic matter, but we haven't seen statistically significant differences yet. Now, there's some things to think about. We are seeing statistically significant increases in soybean yield with the implementation of cover crops. So we know that those cover crops are having an effect and having a benefit, whether it's increased, weed control, moisture retention, water infiltration, something is occurring with those cover crops that's helping to boost or increase our soybean yield. And even though we're not seeing a statistical increase in our soil health yet, we believe that over time, with the continued implementation of these practices, we will start to see those significant increases or changes in those soil health metrics over time, just with continued implementation of these practices. But regardless of whether or not we actually increase the soil health value or soil health index, we are seeing benefits in the yield response of soybean in these crop production systems. The last thing that I want to leave you with is if you are interested in starting to work with cover crops or implement cover crops into your production systems, I do believe that soybean is probably the easiest crop for you to start doing that. I would say they're very forgiving in the sense of with our high seeding rates and our ability to drill or plant those high plant populations, it gives us more flexibility if we do have stand issues. And so that's a good place to start, is looking at cover crops in your soybean rotations. You know, the other thing is try to find a cover crop that best suits, you know, not only your soil, your environment and your crop rotation, but what you're trying to achieve. And so some producers are interested in increasing soil health, some producers are interested in weed suppression, and you really need to pick and choose your cover crop based on those goals that you're interested in achieving from the cover crop implementation. So please keep that in mind. As always, we're here to help. If you have any questions about soil fertility, cover crop, or soil health, please feel free to reach out to us, and we appreciate you joining the Soybean Online Field Day.